11. This afternoon, we are very honored to have invited VIP speakers from 6 most prominent companies in the ICT industries all over the world. They are going to share their insights with you this afternoon. And we believe that this afternoon's conference will lead to a fruitful result to all of you here. Now, to welcome you all, we would like to firstly invite from the organizer, Taiwan External Trade Development Council. Ladies and gentlemen, please join me in welcoming the Executive Vice President of TAITRA, Mr. Walter Ye. 大家掌声欢迎副秘书长上台来为各位致辞。大家再次掌声欢迎。
Distinguished speakers, distinguished guests, ladies and gentlemen, good afternoon. 大家午安。On behalf of organizer TAITRA, I would like to welcome all of you to Taipei, to Computex, and to this forum. And it is always a pleasure to welcome friends, especially those from have traveled so far from abroad to be with us at this forum and Computex. And the show events in its 31st year this year. And now it was among the world's top computer exhibitions. This year, we have 1,800 companies to participate. The scale of the show is 8% of the last year. And also the visitors for last 3 days, also more than last year. We are so glad the performance of this Computex Taipei 2011. We also appreciate very much your support. And the enthusiastic participation in Computex Taipei from the stream of the ICT industry has helped to make the event one of the most important platforms for the ICT industry. And the theme of the show this year is tablet PC, e-book, 3D technology, smartphones, and cloud computing services. And the number of tablet PC exhibitors reached around 50 companies this year. It's a record high for tablet PC. And these 50 companies presenting their cutting-edge tablet PC products at the show. And also this year, we have companies from Taiwan and also abroad introduce their new products here in Taiwan. So you can see all kinds of new products launched here in Taipei. And we also have the DNI Award. We cooperate with IF, the German Design Forum Institute. IF. We cooperate with them to give DNI Award, Design and Innovation Award. It's very important that Taiwan should focus more on innovation for the ICT industries. So this year we have launched a lot of new products here in Taipei from international big names and also local companies. We also invite big buyers from worldwide with over 1 billion US dollars turnover from abroad, and more than 60 companies with turnover more than 100 million US dollars. I think that's very important, the visitors to Computex and to make Computex more successful. And we also have 500 participants from abroad. So about 20% of our exhibitors from overseas. So Computex is truly an international show. And also, the position of Taipei, of Computex Taipei is B2B. We insist to make it a professional trade show for business. So B2B transaction is the most important for these shows. I think this makes it a very important marketplace for the companies to come here. And we are glad the visitors from abroad, about 10% increase so far for last 3 days. And today, forum is also very important to exchange new technology and sharing the know-how and the information with our audience. So today we are so glad to invite the big names to come here to share their experience, their knowledge with us. Today we have the honor to have with us Mr. Boyd Davis, Vice President of Intel Architecture Group, to tell us about leading industry transformation to open data centers and cloud computing. And we have Ian Drew is here, and Executive Vice President of ARM, who present 3E in ever, in power, and in vision. And also we have Mr. Rajiv Ramaswami, Executive Vice President of Broadcom, who addresses driving innovation in the semiconductor industries. And there is also Mr. Manju Hegde, Corporate Vice President of AMD, who discussed the unleashing the full power of PC and software developments for fusion APUs. And also, we have Mr. Lars Oilese, CEO of Opera Software, explores how to capture the markets by using leverage web innovation as a growth strategy. And the last, we have Mr. Steve Owen, Vice President of NXP, and we'll offer tips on mobile transaction, NFC, and payments via mobile phones, tablet PC, and mobile devices. I know these discussions will let us all come out ahead. Please enjoy them, enjoy the show, and enjoy your stay here in Taipei. Thank you very much. 谢谢大家。
Ladies and gentlemen, next we are going to move on to our first keynote speech of this afternoon. We would like to invite the Vice President of Intel Architecture Group, Intel, Mr. Boyd Davis. Mr. Davis is responsible for product and technology marketing for Intel Corporation technology used in data center applications. And in this role, he is engaged in segment marketing, business management, and customer engineering support for various data center group products. Ladies and gentlemen, please once again, welcome Mr. Boyd Davis.
Good afternoon. I'm very excited here to represent Intel's data center group, represent Intel as our company. Maybe you've heard from us earlier this week about the range of devices and the technologies that we're so excited about. And I'm going to spend a few minutes today connecting the devices and those user experiences with the infrastructure and the services used to deliver. But I'd like to start off with a video. That video just shows a little bit of the excitement we have around the data center opportunity driven by the proliferation of compute devices across the compute continuum. Many of you have heard Intel talk over the past several years about this idea of a compute continuum. The idea of computing being embedded into devices from the small embedded devices that manage energy around the world, all the way up through smartphones and tablets and PCs, vehicles, televisions, a full range of capabilities of connected devices. But those connected devices all require services from data center infrastructure increasingly built on cloud architectures. And last year we articulated a vision for cloud computing in 2015. You know, some people will say that if you just buy my product today, you can get the cloud. And at Intel, we believe in a much more powerful vision for cloud computing that really requires our collaboration and our innovation as an industry to address the core challenges around security and scale. We envision a cloud environment that's automated, federated, and client-aware. Automated in the sense that nothing is done manually. You can provision, deploy, and manage workloads automatically and set policies and use the people assets to add significantly more value. Federated in the sense that you can share data, share computing resources securely, whether you have your own infrastructure or you want to work with a public cloud service. And then finally, client-aware. We don't believe that the services should comply to the lowest common denominator. And in fact, the cloud should be smart enough to take a look at the capability of the device and the context of the user and adapt to create the richest possible user experience. And we're actively working with the industry here in Taiwan and the software industry around the world and the overall community of hardware and services and software to make this vision a reality. Now, many people understand this concept of automation and federation, but they get a lot of questions about this concept of client-aware. And we were fortunate enough recently at our Intel Developer Forum in Beijing to highlight an example from one of our partners, Lenovo, who introduced a cloud-ready PC that takes advantage of client awareness in the cloud. And you can see in this example some of the benefits. The first thing you see in the first step is that the cloud can understand the identity of the user in a more secure fashion. The PC has identity built into it, so you not only have the protection of a password, you have that added protection that the cloud knows that the environment, the user is using the device that they said they were going to use. In the second step, the cloud understands the capability of the device, the network connection, the level of security, the level of performance that you can deliver, the level of screen size, the amount of battery life. You have a number of these areas where the cloud can discover and understand the capability of the device to adapt the service. And then in the third step, you see a couple of different scenarios. Maybe there's a rich network connection, so you can have an opportunity to do a full video, audio, and web chat. But in another case, you can observe that the bandwidth isn't sufficient for video, so you can still have a service, but it degrades down to simply text. This is an example of the kind of innovation we're driving to set a standard for how cloud services can discover the capability of the device. And it won't be just PCs, it'll be the full range of devices, and then the cloud can be smart enough to adapt to the capability of the device and deliver a richer service. So we're very excited about the ability to scale the cloud, not only in terms of automation and federation, but also driving client awareness. You know, what's driving this is clearly the proliferation of devices. You've seen this from us for a while now. Over 1 billion new netizens, 1 billion new users on the internet in the next several years. Over 15 billion connected devices. And some people even projected to be higher than that. And we're learning new terms to describe data, from gigabytes to exabytes to petabytes to now zettabytes of data that is being transferred. When we look at the vision for Cloud 2015, it is not simply a way to make the current environment more efficient and less expensive, although that is a huge benefit. We actually need to fundamentally improve the infrastructure to unlock this growth. Ultimately, if we still deploy data center services the way we have over the last decade, the cost and the complexity of the internet services would outweigh the benefits of the devices and in fact limit the growth of our overall business. So at Intel, our core strategy in the data center infrastructure is to unlock the growth potential that we'll all experience in the growth of devices and the richness of user experiences on the internet. An example of this even with the levels of efficiency we're forecasting today, the growth of the smartphone market of just 600 units creates a demand for an additional server. The growth of 122 tablets in the market creates the demand for an additional server. So we're seeing the proliferation of devices correlate to increasing demand for data center infrastructure. So ultimately, Intel's committed to delivering value in this mobile, connected world and based on three primary vectors. One is our core manufacturing capability. Two is our ability to take those designs and build them into solutions that are tailor-made to the user experience. You know, Intel has been in the PC business for a very, very long time. But over the past several years, we've also built purpose-built solutions for the embedded market. We have a lot of success with vehicle companies using our technology to create a rich experience in the vehicles. We've seen us participate in the consumer electronics industry. You know, we have the ability to deliver whatever performance, power, and cost capability is necessary to support a range of devices. Ultimately, that's going to be the key moving forward, is to have the purpose-built technologies that we can work with many of you on to target even a new, broader range of uses. And then finally, we participate in the data center side to make sure that we lower those costs and complexity of delivering the services to make sure that we unlock that growth potential. You know, a lot of people talk about the Intel architecture over the past several years. I remember when I started my career, there was a huge debate that the Intel architecture couldn't get to the levels of performance of the RISC computer architectures back then. That it needed to make a change to a new architecture because there was an intrinsic limitation in the Intel architecture. That wasn't true then. It's not true today that we have intrinsic limitations to our ability to deliver the lowest possible power, the best possible performance, the right cost optimization, or the right features to meet user-driven designs. In fact, the only intrinsic advantage or disadvantage in our business is driven by the manufacturing building block, the transistor. And this is where Intel has maintained and in fact expanded a lead over the last half decade over the rest of the industry, innovating first on high-k metal gate transistors, and with our latest announcement of 22 nanometers to go to a 3D transistor technology. This is the only intrinsic advantage or disadvantage that exists in our industry. And fortunately for Intel, we've invested and innovated to deliver this advantage and have it be the foundation for those designs that we talked about to continue to foster growth in our industry. So let me switch a little bit to talk about the data center infrastructure opportunity itself. We've had a pretty good run. You can see this is the growth of our business from the mid-90s through the last year. And certainly we had a tough year in 2009 together as an industry, but 2010 bounced back far more than people had predicted. So it's easy to say, are we capping out on the limits of growth? Well, based on a variety of factors, we see enormous growth opportunities to come. We expect to double our business in the data center in the next 5 years. And you can see it's not driven by any one segment. We're going to see growth in data center infrastructure for small businesses, for enterprises, in the high-performance computing arena, in the workstation market, and increasingly in new markets like network and storage that are moving away from proprietary architectures that have long development cycles onto a standard architecture, an open architecture that fosters innovation, fosters faster cycle times, and lowers costs. And you can see what our business will be comprised of in that time frame. One of the things you'll notice is, not surprisingly, the cloud services opportunity. Those people that are providing primarily consumer services in the cloud, which are about 10% of our business in 2010, moved to 20% of the business in 2015. Doubling is a percentage of our business on a business itself that is doubling. This market is alive and vibrant. For the next couple of minutes, I'd like to cover some of the most important market segments and give you an example of the kinds of innovations we're trying to enable. And a lot of it is driven here in Taiwan. You know, I've had a great week of talking to a lot of the Taiwanese companies that are taking advantage of this trend toward open systems, toward the need for more efficient cloud computing environments. The transformation in the past year on Taiwan from a year ago talking about the opportunity in the cloud, and this year starting to deliver real solutions with real software has been unbelievable. The industry driven here in Taiwan will be a major force in driving our growth together over the next several years. So let's talk about that cloud services market. I talked about the growth potential. You can see we've more than doubled this business since 2008 despite the downturn. And it's really our intimacy with the customers that's allowing us to do that. We have had an opportunity to earn a lot more of the business as we understood the requirements from a power consumption perspective, from a TCO perspective, from a systems management perspective. By getting intimate with these customers, we've been able to design the underlying technology to meet their needs, lower their cost, enable them to scale a richer, higher quality service, and deliver a better result. And one of the things you'll notice on here is there's many companies that used to deliver technology only through large multinational companies, in many cases now, are customizing solutions directly for the provider of the service. And we're working in every facet to support our largest customers as they innovate at the solution level, to support the ODM community as they take on new customers and new challenges, and to support the end user directly as we understand their requirements. One example of the insight we gained from talking to these customers is a segment that we introduced a couple of years ago at Intel Developer Forum, the microserver segment. You know, most of our industry is going toward larger systems with virtual machines or scaled out applications that take advantage of the compute power driven by Moore's Law. But a small fraction of the market opportunity doesn't have a particular need for significant performance of each individual node, and instead would rather optimize for cost, power, and a performance level that's adequate for the workload. And in those environments, having a dense multi-computer environment with shared power and cooling at a minimum and potentially a shared fabric is a superior solution to the traditional compute architecture. So by working with the large customers in this environment, we're able to standardize a solution with the SSI community here in Taiwan primarily to have a range of performance, power, and price levels within a common standard form factor to lower the development cost and accelerate the cycle time, and yet still meet the needs of these customers who have some unique requirements from traditional enterprises. We're very excited about this segment. It's a very critical segment. We think it could be as much as 10% of the overall market opportunity out in time. Although I think the challenges of having virtualized servers compete with these discrete servers will be a fun battle to watch. We know that this is a critical opportunity in our portfolio. We're also thrilled to have announced earlier this year that we're going to bring the low power capabilities and low cost capabilities of the Atom microarchitecture into the server environment, meeting server requirements. We know server customers demand 64 bits. They demand ECC. They prefer virtualization technologies. And while some software environments are easy to port, the reality is the server environment values compatibility in a significant way. And we're going to bring all of those things, virtualization, ECC, 64 bits, and software compatibility to the market in a sub-10 watt solution in 2012. So we are committed to delivering a broad range of performance, power, and price levels into this environment to meet a broad range of workloads. Another critical segment for us is the enterprise. The enterprise is really driven to achieve the levels of efficiency driven by the public cloud, but with a different set of constraints. And in some cases, those constraints have led us as an industry to propose some proprietary vertically integrated solutions that almost take us back a few years in the computer history. And what end users came to us last year and suggested was they'd like to set requirements for us as an industry that were more open and interoperable, but still allowed them to get the efficiencies and the benefits of cloud computing architectures. Based on our history of bringing the industry together, and based on some of the technical insights we have in the cloud, they asked us to be a technical advisor to a group called the Open Data Center Alliance. The alliance was announced last fall, and the response from the end user community has been immense. It's been enormous. We've seen the organization over double in size since its launch, and the organization is on track to publish the first set of market requirements in the enterprise starting later this month. But one of the things that we also learned is that integration is key. The reality is customers are looking for solutions. And I've been encouraged by the customers I've talked to this week that understanding is very, very well held here in Taiwan. And one of the things Intel has done is said, hey, how can we make sure that you get the benefits of the open interoperable environment with all the benefits of knowing you've got a pre-configured solution? So last year we also launched the Cloud Builders program. And this is a program that brings together the recipes, hardware, software, and deployment for a broad range of cloud usage models, from simply standing up infrastructure as a service, to secure cloud infrastructure, to onboarding, to self-provisioning, and you'll see many more of these in the future. And you can see the list of partners we've assembled to make sure that we deliver an open cloud environment in an easy-to-deploy fashion. The last segment I'd like to talk about is the high-performance computing segment. High-performance computing, as you saw from our model earlier, is going to represent a significant and growing piece of our business. And it's not just in national laboratories or universities doing advanced research. Increasingly, we're seeing those computationally intensive workloads applied to commercial purposes, designing a better product, reducing cycle times, reducing the need for physical prototyping. And that's going to have an opportunity to drive economic expansion globally based on the value of information technology. This is something we've done collectively as an industry for the last several decades. To bring the value of technology to accelerate economic growth in a broader range. We're going to see this affect a lot of things that affect human lives. We're going to see an ability to protect citizens from weather that today comes along unexpected or in a too broad of an area. We're going to see an opportunity to dramatically change healthcare by the ability to not only decode the genome as we've done, but increasingly use that in real time for diagnosis and therapeutic care that's customized to the individual patient. This is a very exciting area for us. You can see that Intel architecture over the past decade has dramatically permeated the high-performance computing environment. You can see the number of the top supercomputers in the world that are based on Intel technology. But again, this is a fast-moving market environment. We know that the workloads, in many cases, have different profiles of how much throughput and how much floating point computational performance is required. So customers are left with a dilemma. Do they take a different architecture and have a relatively invasive rip-up of their code to take advantage of some of the newer technologies for massively parallel workloads? Or is there an opportunity to take the instruction set of the programming tools that they're familiar with and apply them to getting much greater throughput? And to solve that, last year we announced a new architecture in the data center group family, which is the Knights family, or the many integrated core architecture. We're actively in development. We've shipped a software development vehicle to help customers optimize their code, and we're on track for production of these solutions next year. And we're going to give an opportunity to take advantage of the full weight of the fastest floating point throughput computational performance on the planet using the exact same software development tools that customers are used to, where they don't have to optimize and rip up their code and worry about lower levels of microarchitectures. So that's just a quick run through of 3 of the most important segments. You know, the user experience is driving our industry. And the reality is that's going to drive us both on the device side and the cloud side. You know, the innovation really starts with the very best transistors. That's physics. It's the one thing that is the building block that has to be rock solid to have the best designs and the best results for user experiences. You know, cloud computing is inevitable, but it's also an imperative for us. The faster we make it happen, the faster we unlock growth in the devices and the richness of the user experiences. And hopefully in the few minutes I spent with you today, communicated that we've got the right solutions on both the device side and the data center side to help us grow this business collectively. I thank you for your attention. I hope you have a wonderful rest of the show.
Thank you once again for a very informative speech from Mr. Davis. And our next speaker is Mr. Ian Drew. He is the Executive Vice President of Marketing, ARM. Ian Drew joined ARM as Vice President of Segment Marketing in July 2005. And he was responsible for ARM's worldwide segment marketing programs. In 2008, Ian was appointed as Vice President of Marketing, responsible for ARM's corporate marketing strategy across the major markets, such as mobile computing, mobile solutions, and embedded. In 2009, he became EVP Marketing. And before joining ARM, Ian worked at Intel Corp for 14 years in various senior management roles around the world, including Asia, Russia, Europe, and the USA. His last position was the GM of the Russia CIS office in Moscow, responsible for all the sales and marketing activities in the region. Before his GM position in Moscow, he was running Intel's telecom group in Asia. And Ian holds an MS from Durham University and an BEng from Taipei University. And next, he is going to share with us the topic, Enable, Empower, Envision, Connected ARM and Connected World. Ladies and gentlemen, please once again welcome Mr. Ian Drew.
I'm really humbled to be amongst you. I've been coming to Taiwan now for nearly 20 years. I lived in Asia for 5 years, and I've seen the growth of the industry here really explode with the development of PCs, with the development of phones, and really with the development of the economy within inside of Asia, driven by a lot of the people in this room and a lot of the Taiwanese effort that's gone into place. So really what I want to do today is talk to you about how I see the next 5, 10, 15 years developing, and the opportunities for Asia, and in particularly Taiwan, really to drive and take even more of a leadership position with this new and dynamic industry that's developing in front of us. Because the last 30 years of Computex will be nothing compared to the next 10 to 15 with the changes that are going to happen. We really do believe that there is an opportunity for the whole industry here to take a huge step change and really drive towards new business, new economies, and really into new markets. So let me tell you how I think this is going to work. As typical, first slide doesn't work. When I first started coming to Taiwan, the internet was still in its infancy. But back in 2003, when I first came to Asia, and I lived over here, there was one PC for about every 20 people on the planet. And people went, wow, isn't this good? Perhaps we could grow to 1 in 5 or 1 in 3. And maybe that will be the where it stops. Typical. When you look at it at the moment, there's one connected device for every person on the planet. In fact, you could probably take it to about 2 by the end of this year, the way that phones and tablets and digital TVs are all becoming connected. But that's not the end of it, that's really just the start of it. Because if you look in a few years in advance, you're going to get one person to every 120 connected devices. Now think about this. When it was 1-to-1 or 1-to-2, you could say that those devices looked the same. You could see some standardization. But when it's 1-to-120, what you really have there is an opportunity to really differentiate and put in value-added services and change the definition of what a connected device really is. It will be connected washing machines. It will be your connected home. It will be secure devices in your credit card that continually monitor where and what you are. It will be a laptop, it will be a PC, it will be a phone. It will be multiple things that connect you to the world and connect the world to you, driving huge infrastructure needs, driving huge opportunities at the back end to really change the way in which this industry moves forward. So, I think the change over the last few years has come from standardization. I think the next few years are going to be always on, always connected, differentiated, connected for you, personalized for you. And that's where I think Taiwan and Asia can really drive what's going on. A little bit about ARM. ARM is an intellectual property company. We don't make chips, we license them out. We license to over 250 companies now. Last year our partners, and we use this word very, very carefully because we really do mean partnerships. Our partners sold over 6 billion parts. Everything from embedded controllers in the home, through PCs and laptops, through digital TVs. And just recently, a few reports came out and said ARM architecture had more revenue than either PowerPC or x86. The first time ever, ARM architecture now is #1 in dollars, and we're very proud of that. Number two, about 30% of all the application processors, the microcontrollers on the planet are ARM. Huge growth in this industry, driven by Asia, driven by designs here, driven by opportunities here. The third one, this is not just driven by the old style companies. 25% of our licensees are new and startup and innovative companies, driving growth and changing the way that we do business. One thing that we've noticed in this industry, every time there's a change, there's winners and losers. And we think as you move from this standardized world into this connected everywhere world, there is huge opportunities for local players to really drive differentiation and go and win against the big guys. Because when there is change, there is opportunities to win. And we believe the people at Computex this year will really see the change of that happening over the next few years. But more interestingly, Asia drives our revenue. Asia has huge heart for ARM because this is where IT happens. Nearly 50% of our revenue comes from Asia. We think this is the lifeblood of the IT industry. And probably more than that, if you add in all the manufacturing that goes on at the foundries, add on to that all of the opportunities to manufacture in China, in Taiwan, in Korea, and Japan. We think there is huge growth here, and we continue to invest in Asia. So enough about ARM. I wanted to look at where we see the industry growing. And this is a profile of the whole industry. Over on the right-hand side, you have sub-50-cent microcontrollers. On the left-hand side, you have high-performance computing, stuff that Boyd talked about today, cloud computers. And this is a rough profile of where our royalties come from. So most of the royalties at the moment come from that middle bit. The tablets, the phones, the connected devices. We see that as the last few years growing quite substantially. And that's been driving Intel's Xeon business. As Boyd told you, you can see 600 phones equals 1 Xeon processor. You can see 122 tablets equals 1 Xeon processor. That growth has really enabled Intel's data center to grow. And so you've seen the growth curve go up like this over the last few years. But it doesn't just stop there. If you really do believe in the connected device everywhere, you really do believe in sensors everywhere, you really do believe that you can put a 2 square millimeter processor with a radio on into somebody's eye, then you will see a profile significantly more like this, where your devices are connected all of the time, and they go from the digital TV all the way down to where we used to think 8051s go. But it doesn't just stop there. As we see a growth in cloud computing, we also see a need for not tens of watts of power, but single-digit 1, 2, 3 watts of power into servers. And we see growth at the right-hand side as well. So going up into this cloud computing environment over the next few years, really enabling low-power supercomputers, blade servers to grow. And we see ARM as a driving factor in that, but we also see huge partnership opportunities as well, because we won't be doing this ourselves. Because we're a licensing IP model, we have to do it with partners, through partners, with partnerships in software, with partnerships in ODMs, with partnerships in semiconductor companies. We believe this huge spectrum from sub 50 cents all the way through to supercomputers and $200 plus SoCs. We're the only architecture that can really span that across a whole range of partnerships. And this partnership word keeps on coming up, and I'll explain to you why in a minute. Outsourcing. I was looking at what I really felt was the genesis of where Taiwan's industry came from. And it came from outsourcing manufacturing, low-cost design. And then you went into more value-added services on top. More software, more putting the components together, the motherboard design. And then I looked at really where things were going in this area, and I thought there was huge opportunity there. So a few facts in that area that really, I think we should take note, because they will be the driving force going forward. We think it's much cheaper to outsource some of the key components in the industry and add value on top. We think it's about 60% cheaper to go buy an ARM core than it is to design your own core. And we've proved that out time and time again. It's faster, it's better, it has lots more software compatibility. We think that partnerships are critical. We have 850 partners in our Connected Community program. The fastest growing part of that is in Asia. We have a third of those 850 partners in Asia driving software and hardware innovation. But more interestingly, we have a unique business model in IP where we don't make money unless our partners make money. Because we have a license and royalty model, if our partners don't ship, we don't get royalty from that. And that's really where our profit comes from. And so we are taking a risk together. We don't just put together a vertical solution. We have to enable this industry with an ecosystem to grow. And that's the way the profitability is shared. By selling things, by doing things together. And that's how partnership becomes about in a real win-win environment. And we see that moving forward as the best way to attack the 120 different connected devices that you will have around you in the next 5 years. It wasn't the way 5 years ago. We believe in the next 5 to 10 years it will be the way forward. So, a history lesson. In the 80s, computing and technology was driven by functionality. Supercomputers were there to go check the weather forecast, do big back-end systems for businesses. Functionality was the thing moving forward. And then Taiwan came about. And what did you guys drive? The PC industry. Standardization, low cost, so it really became functionality over dollars. How much could you do at a price point? And that drove things like $1,000 PC. I remember working in the industry going, we can never get to a $1,000 PC. Now almost all PCs are sold below $1,000. Driven by cost saving and standardization. Then after that, it was laptops, which was really functionality over power and cost. You took that PC environment and we worked together as an industry to take the big heat sinks off and have small heat sinks, to get everything into a very small package, to have battery technology on there. That was driven by Asian companies innovating to go and drive new and exceptional growth areas. And then we get to where we are today, which is really functionality over energy. And the difference between energy and power is energy is really efficient use of power. How do you take what you have and use every atom and electron efficiently to get the job done. And so it's a core change in design that allows you to have no heat sinks, really thin devices, batteries that will last all day, as opposed to 3 or 4 hours. Lightweight consumer products, which is really what's driven the tablet market. And when you walk around the show, you see hundreds of tablets now. And it's really this functionality over energy and cost. And that's driven by what's gone on over the last few years. But where's this going? The next area is critically related to the 120 connected devices that will be around. And we see its functionality over available energy. That means when you're connected, when you're not connected, how do you get energy into devices? Does it harvest from everybody's phone in here, the energy that's in here? Does it sit there and harvest it from the lights or from solar electricity? You have a difference in the way you gather electricity, the difference in the way that you use electricity. And consumers value thinness, lightness. And if they value that thinness and lightness, you need to find ways to recharge, you need to find ways to enable much better energy efficiency. And so that will enable new devices. My watch may become a computer, or some other device that's connected. Medical will use this, not just to go and analyze, but to go and embed. And so we see huge growth area potential for diversifying this business. Not just taking the standards, but adding an awful lot of differentiation. And differentiation means value, means margin, means money. But after that, we've gone through the power cycle. What's next? Battery technology. Different semiconductor industries happen. We're still evaluating all of that. We think that's a 10-year in advance. So, I've explained about low power, but I think low power hardware is really the future driver. Low power by design from day one. Design philosophies to drive low power will be critical. And you can't do that by categorizing. You have to have innovation. And we deliberately drew the slide previously, with a line going from phones all the way through to DTVs. Why is that? Well, actually, don't agree in categorizing products. When you categorize products, what do? You take away innovation. And so why do we work with 250 companies for SoC level? Why do we work with 850 connected community partners? Because we don't categorize into one area. We enable differentiation. We enable this whole slew of products through a product range. What does that mean? End users get to choose. That means you get to design the products that you think are right for your market. And you can pick and choose which partners you want to work with and pick the best in the industry and mix and match and put them together. Because we believe the OEMs, the ODMs, really are the people who should be able to pick and choose which categories they want to play in, what new categories they want to create, and really where the end users are going. So you should not have a reason not to do a product. It's your own ideas that should really come to the fore. And that's what I think Asia and Taiwan can drive. Software. I joined ARM 6 years ago, and everybody said Symbian was the way forward. Over the last 6 years, we've seen the growth of the browser, we've seen the growth of the internet everywhere, we've seen the growth of mobility. It's been driven by operating system choice, browser choice, plugin choice. We've seen hundreds and thousands of applications being written and downloaded. We see Google Android doing hundreds of thousands of downloads a day. We see Chrome OS. You've seen announcements today from Windows 8. It's really enabling this internet everywhere story. Not just for browsers, not just for plugins, but for the applications they actually use. And this is driving the internet to become more personal for you. But what else they're doing is they're driving this connected everywhere. Because these applications really need the internet and really need the personalization of you to drive this forward. So I think there is a misnomer in this industry, and that's called the personal computer. I think your phone, your tablet, and all the rest of the 120 devices that will be around you coming forward will be your personal computer, because they are more personal to you than your PC is. We see software driving that, we see innovation driving that forward. So, in conclusion, we think partnerships are important. I've mentioned partnerships on every slide. We are a partnership-driven company. We don't make money unless our partners make money. We don't think that partnership should be one size fits all. We think partnership should be around differentiation. We think partnership should be around innovation. We think partnership should be around risk and reward. And multiple choice is significantly better than one size fits all. We see a growth from the mini computer through the PC era to the tens and hundreds of billions of units. And that means huge opportunity moving forward. And my challenge for you, having been at Computex this year, is how do we speed that up? Because Computex is changing. Because Computex is becoming the IT trade show on the planet. How do we take opportunity of hundreds of billions of units and really drive the creativity of Taiwan, of driving innovation, demand, cost, functionality to make an industry that is again world-class, because we see this as the next 10 years of opportunity for this trade show, and the next 10 years of innovation in Taiwan. Thank you very much indeed for your time. I really appreciate this. I'd like to thank Tetra for putting on a great trade show. Thank you very much.
Executive Vice President of our Mr. Andrew, and our next speaker is Mr. Rajiv Ramaswami, the Executive Vice President of Broadcom Corporation. Mr. Ramaswami was previously at Cisco Systems, where he most recently served as Vice President and General Manager of the Cloud Services and Switching Technology Group. And he joined Cisco in 2002 and served as Vice President and General Manager for the variety of business units in optical, switching, and storage networking. And then Mr. Ramaswamy joined Broadcom Corporation and was named Executive Vice President and General Manager of Infrastructure and Networking Group in 2010. The Infrastructure and Networking Group, headed by Mr. Rajiv Ramaswamy, is responsible for all Ethernet controller, switching and physical layer products, optical solutions, storage products, security, and embedded processors. The group's products and technologies are targeted to enterprise-wide area network, metropolitan, small to medium-sized business, and small office, home office markets. Ladies and gentlemen, next, Mr. Rajiv Ramaswamy is going to talk about driving innovation in the semiconductor industry. And for I'll give you a little bit more introduction to Broadcom Corporation. Broadcom Corporation is a prominent technology innovator and global leader in semiconductors for wired and wireless communications. Broadcom products enable the delivery of voice, video, data, and multimedia to and throughout the home, the office, and the mobile environment. And Broadcom Corporation provides the industry's broadest portfolio of state-of-the-art system on a chip and embedded software solutions to manufacturers of computing and networking equipment, digital entertainment, and broadband access products, and mobile devices.
Great.
Thank you so much. And ladies and gentlemen, please welcome Mr. Rajiv Ramaswami.
Thank you. I'm very glad to be here at Computex, and as you can all see, this show is really changing, and it's really gone from being a PC show to now what we consider to be the preeminent IT show. And what I'm going to be talking about in the next 20 minutes or so really is in two parts. The first part is all about how can we continue to drive innovation in our business, in the semiconductor industry. What are some of these challenges that we see as we go forward, and how are we going to address those challenges? And I'll share with you Broadcom's recipe for success in this market. The second part of this is going to be all about the data center and the data center networking portion, given the relevance of data center to the show and going forward, and how we are taking some of those learnings in terms of innovation and applying them to delivering successful products in the data center, and how that's being transformed. So, two parts, and let's get going here. So if you look at the fundamental challenge that we face in the semiconductor industry, over the last 10 years, if you've looked at it, the dashed lines over there indicate the rate of revenue growth for the entire industry. And the solid line above is the R&D dollars that the industry is spending. The fundamental challenge, as you can see at the bottom in the green bar, is that R&D is growing at a faster pace than revenue for the industry. That creates a problem, as you can see. Why is this happening? Well, our business is getting more and more complicated. Right? The system on chips, we have a lot more intellectual property into these chips. It allows the OEMs to push more and more of the R&D burden down the food chain to folks such as ourselves who build the chips. These chips are getting more complex. They're getting smaller, they're getting smarter, they're getting faster. The digital, there's mixed signal, there's analog, right? All of which get combined together into an SoC. At the same time, the software effort on these chips is growing dramatically. In fact, it's surprising, right? Broadcom, for a company our size, still more than 75% of our population is engineers. And in fact, a big chunk of them, in fact, I would say the majority of them are now software engineers, indicating that the rate at which our business is changing. Fundamentally, again, Moore's law is moving faster than the rate at which engineers can keep up in terms of productivity. So these are all some of the challenges that we face fundamentally in our industry. And as you can see here, if you look at what customers, what the OEMs are doing in this business, whether it's PC OEMs, whether it's communications OEMs, whether it's handsets, or consumer electronics, as you can see from there, the trend is that the OEM R&D intensity is coming down over the years, and more of that R&D is being pushed down to the semi-industry. So our industry is, of course, responding. We are spending more, right? The OEMs are spending less. Our R&D burn is going up. And at the same time, we all know this, right? Every time as we've gone from, 0.18 to 0.13 to 90 nanometers to 65 nanometers, and then now on to 40 and 28, the complexity is growing exponentially as we go through these process nodes. And yet we have to go through these process nodes fairly quickly for us to keep up the pace of innovation. So I think we're starting to get a picture of what are some of the challenges that we face in the business. How are we solving it? I'll talk about three fundamental tenets that we use at Broadcom to go address these problems. And I think we've been using them for many years, and it's been a recipe that has worked very well for us, and I think it will work well for other people too. So the first thing is we look at sharing of intellectual property as a competitive advantage. So the philosophy at Broadcom is, we have 20 lines of businesses developing a whole variety of products all the way from consumer electronics on one side to, carrier-grade, service provider routers on the other extreme, right? And so a whole range of products, but there's a lot of intellectual property being developed in the company. And all of this is freely accessible to anybody, any group, anywhere in the company to use. So this greatly simplifies the ability for a particular group, a particular product to be built. So if we want to build, if my group wants to build an SoC for a particular application, we get the luxury of pulling IP from every other group in the company that's already been developed and put it together into a chip. So this, of course, simplifies and accelerates our development cycle dramatically. Right? It allows us to get much better performance, lots more features than doing everything from scratch. It's just some of these projects we would never be able to do from scratch if we had to reinvent the wheel all over again for every feature that was needed. Right? It allows us to get better integration and reduce the amount of board space and power consumption and get to the lowest product cost structure. So fundamentally, this is something that we do. We have a very systematic way of sharing IP in the company, where whenever somebody builds a core, it actually gets put into a central library and it's designed in a way that other groups can use it. And it's, I think, critical. And this is, again, a reason why scale is so important in this business, right? Because a company like us that has the luxury of scale has the ability to pull IP from many different parts to go succeeding. The second tenet that we have is integration. If you take an example, right, in my group we do Ethernet switches. And if you look at the various components in an Ethernet switch, it's quite a complicated SoC. You've got memory, you've got for the buffering, you've got things like access control list, you've got interfaces such as PCI Express, you've got power management, you've got packet buffers, you've got packet processing, you've got SerDeses, you've got physical media devices, you've got CPUs, all of which are part of this SoC. And you can see an example of how each of these is being done by a different group within the company. And we have the ability to pull all of these together to put together an Ethernet switch. And again, something like this, doing this level of integration is critical for us to deliver world-class products. The last piece, in terms of how we go about doing this, is we keep up with the technology nodes. We're very quick to adopt new process nodes because that's really how we get more integration, that's how we get more for less. Right? So we've been shipping 65 nanometers since 2008, and that's the bulk of our volume today. Since last year we've been shipping 40 nanometers. In the infrastructure group, my products, we have a whole range at this point in 40, and of course we're working on 28 nanometers as we go forward. And with every generation, we're able to get more and more silicon content into a single chip. As an example, in 65 nanometers, we were able to put 24 ports of 10 gigabits on a single chip, on an SoC. When we got to 40, last year, we started shipping 64 ports of 10 gigabit on a single chip. That's 640 gigabits per second. And you can imagine that you're going to see SoCs in 28 and beyond that are going to have more than a terabit per second worth of capacity on a single chip. It's a terabit. Quite a lot, right? So this is not going to slow down. This integration is going to continue, and you're going to see more and more with every generation of product and every generation of technology. So that's sort of how we address the problem of innovation in general, right? We using the IP blocks that we generate, build as a company, integrating all of those and moving to process geometries. Now let's talk specifically about the data center and how we're driving innovation in the data center, particularly from a networking perspective. So the data center is changing a lot, right? We've all heard a lot about cloud computing, we've heard a lot about virtualization, and all of this is resulting in large-scale data centers being built out with thousands of servers interconnected by a very large-scale networking fabric. And if you look at what these kind of data centers need, these large internet data centers need, right, from a fabric perspective, from a networking perspective, they need the scale first. Right? You can imagine, your data centers that are now 100 megawatts, right? The very large cloud data centers dissipate enough energy, as much energy as entire cities do, or more, right? 100 megawatts plus per data center. And the scale is massive, right? Tens of thousands of servers in a given data center. Okay? Virtualization is getting to be more and more pervasive. If you talk to enterprises, they'll tell you that, you know, give or take 30 to 50% of their infrastructure is now virtualized. Convergence. Your convergence of different protocols, convergence of storage, convergence of high performance computing, convergence of networking, everything onto a common fabric, as opposed to deploying separate data center networks and fabrics for every one of these. Latency. Being able to have predictable, low latency in your networking infrastructure is critical. And the last but not the least, as everybody here has talked about already, energy efficiency is extremely critical. Right? When you just think about these, 100 megawatt data centers, you're limited today in what you can put in the data center primarily by power. Right? That's what determines how much you can pack in. And you can imagine, right? Capacities continue to grow, compute capacity grows, storage capacity grows, yet you can't afford to scale power linearly. So these are the challenges. So how are we addressing them? Okay. The first is this notion of convergence. Let's talk about convergence. So this convergence in the data center is happening over 10 gigabit Ethernet. So if you look at it today, there's a lot of gigabit Ethernet in the data center. There's a lot of fiber channel. There's some InfiniBand. And if you look at where this entire industry is headed, it's 10 gigabit Ethernet, where you're going to have your traditional networking traffic, your NAS traffic for storage in terms of file storage, and for block storage, you're going to have either iSCSI or fiber channel, all running over Ethernet. And then finally, the last piece of InfiniBand for high performance computing is also going to be running over low latency Ethernet. So you can imagine how all of these fabrics are coming together and consolidated right from the server onwards into the rest of the network through 10 gigabit Ethernet. This is a big transition in the industry. So let's take a look at this picture from the top down or from the bottom up here. So let's start with the servers here. So you have rack servers, you have blade servers that are virtualized, running virtual machines. Today, if you look at the industry, there's about 8 million x86 servers sold on an annual basis. And that's growing at about 5 to 6% per year, despite massive virtualization. Now, out of those 8 million servers, about 15% of them are blade servers, and those blade servers today, for the most part, have moved to 10 gigabit Ethernet I/O already. The remaining 85% of those servers, mainstream rack and tower servers, are all sitting today at a gigabit per second I/O. Now, what's happening is, with the next CPU cycle refresh, all of these servers are going to 10 gigabit. So every OEM is going to be introducing, having 10 gigabit as an option on their mainstream rack servers, the remaining 85% of this 8 million server market. Why do you need to go to 10 gigabits? Because of virtualization, because of higher performance CPUs, and because of the convergence that we just talked about. You are going to drive a lot more I/O out of these servers. Multi-core CPUs, multi-core many sockets, that are all virtualized, driving a lot of I/O. So that's a massive migration. Over the next 5 years, you're going to see these 8 million servers all migrate from gigabit Ethernet to 10 gigabit Ethernet. As that happens, what you're going to see here is everything that those servers are connected to sitting above, the top of rack network switches, and the aggregation layer beyond that are going to go up as well. Today, those top of rack switches are primarily gigabit switches, but now they're all going to 10 gigabits per second. And then if you look at further up in the network, at the hierarchy, the core and aggregation layers, you're going to see 40 gigabits per second. So this transformation of the data center is going to happen. It's already happening now, and it's going to happen continuously for the next several years to come. So how are we addressing this market? So if you look at starting within the servers, right, we have a full portfolio of 10 gigabit Ethernet controllers. These are again 40 nanometer silicon. They have high performance. They have converged storage. They do everything from native Ethernet traffic to storage traffic to low latency Ethernet. All of which are done together on these controllers coming out of these servers. Okay, highly energy efficient. And then if you look at the physical layer devices, Again, energy efficient Ethernet, 5 across the board, critical. And then if you look at the switching portfolio there, we were the first to introduce high density 10 gigabit switches into the market. We introduced our switches early last year. And since then, now today, we have many customers and many ODMs here in Taiwan now shipping 10 gigabit switches using our silicon. And this is again a market that's just getting ready to explode at this point. And then as we get up into the very scalable infrastructure piece of this, today we have 100 gigabits per second silicon today already in the market. And so you have 40 gig and 100 gig starting to happen in the core, very large scalable devices happening there. Now, at the end of the day, what this does for you, and how are we doing this, right? We are addressing all these problems, right? Low latency, end-to-end quality of service, very high scale, connecting tens of thousands of servers that are all very resilient. We're doing that using the same three things that we talked about before, right? IP blocks that we get from different pieces, different portions of the company, putting it together into these solutions. For example, on the server motherboard, we're able to take, controller solutions and integrate them with the physical layer backplane solutions that we have, as well as the front panel solutions we have, right? If you take the switches, we're able to do the same thing with the switches, right? Integration, moving to, a lot of integration, sharing of IP blocks integration, and then finally moving to 40 nanometer process geometries across the board, right? That's what we've done here to get to the solution. Let's talk a little bit about energy efficiency, since this is just top of mind for everybody. How are we addressing energy efficiency? Now, energy efficiency is not just one thing. It's a collection of, we have to take a holistic approach to energy efficiency. It's about doing many, many different pieces. It's not that there's one solution that takes care of the problem. There's many different levels. And if you look at the networking portion of this data center, there's many different pieces. Let me talk about the 4 pieces that are here. If you look at the top left, energy efficient Ethernet was a standard that Broadcom drove, and it was adopted and formally ratified last year. And what energy efficient Ethernet does is that, what you realize is that you're not always transmitting on the link. A lot of the time, your links are idle. And when you're not really transmitting a lot of traffic, you have the ability to put the physical layer into what's called a low power idle mode. That can save significant energy consumption. In fact, over there you can see up to 70% savings in energy just on the link. Right? So that's the first component, and every product today in our portfolio supports energy efficient Ethernet. We don't stop there though. That's the first piece. The second piece of that is energy efficient networking, what we call energy efficient networking, which is taking a look at this network from an end-to-end perspective and saying, hey, when do you need to turn the link down? And if the link is going, if you're going to put the link down, then can we also turn off everything else that's behind it? Can we turn off the switches? Can we turn off other portions of the device? And so, doing this in a very coordinated manner to reduce the energy consumption across the entire network, not just in the physical layer only. Right? So we do that today, and that again provides additional savings. And of course, as we go from one process geometry to the next, as you go from 65 to 40, for example, that of course you get, every time you make that step, you get additional benefits in terms of energy per unit bandwidth delivered. Right? So we're doing that. We're of course trying to pack more and more into each of these steps. But then if you look at what you're driving in terms of energy per unit bandwidth, it's continuously coming down. The last piece of it is what we call stateless and stateful offloads. So one of the things we try to do here is if you're on a server is spending a lot of its CPU cycles doing I/O. And what we try to do, being a communications company, is we try to offload that as much as possible onto dedicated hardware in the controllers. So what that does is 2 things. It frees up the CPU to do your compute tasks instead of actually spending your time doing I/O processing. And second, it dramatically reduces energy consumption, up to 100 watts per server with all the offloads that we do. And that's 2,000 watts per rack, and that can be very, very significant. So as you can see, the way to address energy efficiency in the data center is not through one, magic trick that takes care of the problem, but to look at every facet, every place where you can save energy, and work hard at it from every different angle. That's what we do here. So, let me close by talking again about the challenges we talked about and how we're solving them. So the fundamental challenges we have as an industry today are our R&D intensity is increasing relatively. It will continue to increase over time. It's not going to go down. Right? IC design complexity, system on chip, software complexity continues to go up. How are we solving that? We're solving that through three things again. Right? Broad IP portfolio, systematic IP sharing across different groups, high levels of integration in our SoCs, and by migrating using Moore's law, right? Effectively, migrate to the next possible geometry as quickly as you can to continue to drive productivity. Right? That's how we solve it. And if you look at how we're applying all of that to the data center in terms of solving the data center problems that we talked about, scale, virtualization, convergence, latency, energy efficiency, we're doing that. We're applying all those principles to creating an end-to-end portfolio of SoCs. Today it's all at 40 nanometers, end-to-end, starting from within the server controllers, through the physical media devices, all the way through to blade rack switches, and then the core and aggregation levels, scalable fabric switches. When we look at the problem of energy efficiency, we tackle it in a holistic way. Right? Not, as I said, one size fits all. Many different pieces come together into an overall portfolio that delivers on energy efficiency. So I think this is what it's going to take for the industry to succeed. It's going to get more and more complicated, but the good news here is that we get the ability to add more and more value in our solutions and integrate and produce, drive the innovation in the industry. So with that, let me stop. Thank you.
Thank you once again to the presentation of Mr. Ramaswami. Ladies and gentlemen, next we are going to take a 10-minute break. We have refreshments and beverages ready on the side of the auditorium. Please be back by 4 o'clock. Our next